My name is Ronnie Cesana. I'm a developer at ThoughtWorks Italy. I'm just going to say a couple of words on what ThoughtWorks is and what ShareIT, the community, is, and then I will leave you to our guest for tonight. I'll start sharing my screen. I hope you can see that. Okay. So what is ThoughtWorks? For those of you who don't know ThoughtWorks, ThoughtWorks is a global community, a global consultancy organization. As you can see from this nice slide, we have operations and offices in many different countries. Probably we should update the number of employees, but we hit 10,000 plus. So what do? We are all fond of technology. We are a consultancy in that in the IT space. You might know ThoughtWorks from some of the books that you can see on this slide. You might know of ThoughtWorks for our blog posts, Martin Fowler blog probably, or the Tech Radar. The Tech Radar is a technology review that is being published by ThoughtWorks for quite some time now. Why do we have all these books? And why are all the thought workers actually encouraged to write a book and share their knowledge? Because it's actually part of our DNA. We think that sharing our knowledge and improving the way we do IT is part of what we do, not just consulting on the very project that we do. What is the ShareIT or ShareIT, as I said, community? It's a IT, it's an Italian technology community, and we want to share our experience, not just in technology, but in everything we do, actually, in our work days. Our mission is to empower individuals and organizations, and the way we do that is by having regular events. We do this we try and do this once a month, where we share our experience about architecture, technology, design, but also practices, the way we do agile, the team practices, and everything around what we think is improving the world with technology. So that includes diversity and inclusion and the way we live our life in ThoughtWorks. In the talk today that our guest will deliver to you, you will be able to interact. There's a chat feature, of course, in Zoom, and there will be questions that you can ask Andrew. I will introduce him in a second. So we have a little code of conduct because of this interaction. It can be summarized as be excellent to each other. Briefly, any question is a valid question. We are all here to learn, so we have to acknowledge that, and there's no silly question, right? Be kind and respectful to each other in the way you express your ideas, and be welcoming to other people's ideas. And again, we're all here to learn. Okay. And here comes our guest tonight. So Andrew Harmel, he will introduce himself, but he's a thought worker from ThoughtWorks UK. He will talk about the varieties of development experience. I will leave it to him in a second. Just remember, feel free to use the chat if you want to drop comments also with other participants. If you want to ask questions, please use the Q&A function. If anybody among you is slightly more comfortable asking questions in Italian, there's no issue. We can translate for Andrew. And I will leave it to Andrew. Enjoy your talk.
Thanks, Ronnie. I'll just find my slides to share. Oh, I need to start presenting so I don't do the annoying thing where everybody. There are my slides. I'll find Zoom. Here we go. Hopefully everybody can see that. Can everybody see that? I'm assuming somebody can say thumbs up or something in the chat.
I can, yes.
Oh, good. Right. Awesome.
Yes.
So cool. Yeah. So thanks, Ronnie. Yeah. What I'd like to talk about over the next hour or 50 minutes, because I'd love to leave some time at questions, because this is, as I said in chat a minute ago, is something I really love to talk about. This is a talk. So as Ronnie said, I'm a tech principal at ThoughtWorks. So it means I'm a senior technical person, but I've been doing development for a long time. And what I want to share over the next 45 to 50 minutes, and then, like I say, we can have loads of questions and stuff at the end, but please put them into the Q&A as we go, and then we can get to them at the end. I want to share a story about, or a kind of long story about my experience of writing code, and my experience of other people writing code, and my experience of working with other people writing code. And it's a interesting story because it's quite a hard talk to give, or it was a bit scary the first time I did it. This is the second time I've done it, because I've tried to write it and be quite open and honest and talk about things which I'm not sure we talk about enough as software developers, whether we're expert software developers or whether we're just starting out, right? We literally just graduated from a course or have done some self-learning stuff. And there's some stuff we don't talk about, which I think we should talk about, and that's why I wrote this talk. So what I'm going to cover in the next set of slides, and I've got hopefully not many slides and hopefully lots of information and sharing, I'm going to talk about my trip to a conference, I think 7 or 8 or maybe 9 years ago, which, despite the fact the conference might sound like an awesome place to be, there was something that happened to me at that conference which had a significant effect on how I thought about how I wrote code, and kind of shook my confidence about it. And because it shook my confidence so significantly, it then kind of caused me to worry about things which we'll talk about specifically. And I worried about it for so many years. I split that problem down into kind of 5 sub problems, because I'm a developer, so I like to split things down into smaller pieces. And as a result of those kind of problems, I had further kind of crises of confidence. And so I'm going to share those things with you. And what I'm going to try and do is not just share my crises, but also share the questions that it made me ask myself. And so maybe, hopefully I don't depress you as much as I felt at certain points in my experiences, but hopefully I can kind of challenge you with some of the questions that I felt and make you think about the things that I thought about. And I'm also going to share with you some kind of conclusions that I came to, and some explanations that I have, to me anyway, make a lot of sense, and hopefully pull lots of this stuff back together. And consequently, and this is why I've now written this talk, how I think paying attention to these things and paying attention to the varieties of development experience, or paying attention to how different development feels to different people and different ones of us at different times in our career, how we can pay attention to that and use it to become better developers, better peers and partners, better learners, better contributors to open source communities, et cetera, et cetera. So I'm going to talk about that. That's the things I'm going to talk about. So 1 big question, 5 small questions, and I'm going to pull it all together at the end and try and explain how I think we can use this to make ourselves better. That sounds a bit negative, but it's not negative, right? The first kind of thing I want to make clear is writing code is awesome. And I think this is the first thing that strikes it. I think it's one of the reasons why lots of us get into software development, because the act of development is not like many other jobs, right? The act of writing code gives us a hit that compared to some of my other friends who do things that they love, very few of them seem to get the benefit and experience the depth of experience that we get when we write code. It's so good. Lots of us do it for free. We do open source, et cetera, right? So, and to prove that it's not just me that thinks that, I'm going to kick off with a quote. So, and you can in chat. So this one actually, this is quite a long quote. So I'll pause for a second while everyone reads it. But the question to everyone in the audience is, do you know who said this quote? So that's the first audience participation element. So if you put in guess in chat who you think it is, when you've read it, obviously. And there's no silly guesses, but there is one right answer. Oh, good guess. It's not Kent Beck. It is a white person, but they're dead. No, not Donald Knuth. Wait for one more guess. Ada Lovelace. No, not Ada Lovelace. It's a bloke. It's a man. It's actually Steve Jobs. So it's Steve Jobs talking there's a 1990s documentary that's available in 3 parts on YouTube. It's really fun to watch, called Triumph of the Nerds. But Steve, even Steve, who didn't actually spend his whole career writing things, really nicely summed up how it feels to write code, right? It's like an incredibly thrilling experience is exactly what lots of us feel. So the next quote, does anyone know who this is? So I'll pause again because it's a bit long. Any guesses? This person's also dead, if that helps. No, not Carl Sagan. Good guess, though. Einstein, nope. Wait for one more guess. Von Neumann, no, it's actually Vanessa was right. So this is Ada Lovelace. So this is the person who basically invented our career, right? Invented computer programming before computers existed, or before the computers we know about today. The ones that von Neumann invented and stuff. Ada Lovelace was pointing out also the kind of the depth of experience, but also it's interesting here. Ada Lovelace, a woman, not a white kind of super rich Western male like Steve Jobs. She was talking about how the fact that she's struggling to understand, to kind of get her head around all of the concepts. She's aware of the depth and the breadth and the size of what this thing that we do, which is computer programming, how powerful it can be. So I've got one more quote, because these are 2 bits I'll pick up in a second, but there's one more quote which I'm going to use to kind of introduce the third theme, which I'm going to talk about. So does anybody know who this is? I don't think this person is dead, but this person is a white Western male. But this one's the most famous quote, so maybe somebody will guess this one. And I'll wait for 2 guesses because everyone's probably like, just hurry up. And it's not anyone that has already been guessed either. Any thoughts? So I'll put everyone out of their misery. This one is Fred Brooks talking in the Mythical Man month. And so what I want to do is pull out 3 things from these quotes. I want to pull out the fact that, as I said at the start, writing code feels awesome, right? Feels, not intellectual. Intellectually, it's an exciting challenge, but the feelings which code and writing code can give us can be incredibly high, right? We can experience real heights of emotion, real positive emotions. But the thing I want to pull out from the Ada Lovelace quote is also there can be like lows of emotion, right? Writing code can feel flipping horrible, right? We can feel like the dumbest people. We can lose sleep. We can, really not great things can happen to us as a consequence of writing code. And the reason I've got the Fred Brooks quote is, which this is quoted a lot, but I don't think anyone looks into it. And this is what kind of sparked this investigation. The reasons I think it can be high and low is because, as Fred says, we build castles in the air, right? With our minds alone, we are creating things that are super powerful, right? We can create with not very many lines of code, compared to like the effort you need to do to go in to build a massive building. We can build spectacular structures in code with very little effort in the grand scheme of things, right? But we can also build absolute complete messes, things we don't understand, things which challenge us, things which crush us emotionally with an equally small amount of effort. So that's kind of those are the themes I want you to keep in mind as we go through this, and I'll kind of explain my personal journey and hopefully examine them and think about them and dig into them a bit and maybe pull some conclusions from it. So I said there was one big question, and then there's 5 smaller questions, and then we'll come back to this big question. So my big question that I want everyone to, or I'd like everyone to consider is, how do I know, and this was a question I asked myself, how do I know if I'm doing development right? So how do we know? And the thing that sparked this is like I said, it was a tale of pretty high privilege where I'd been paid by my job to go to an open spaces conference in Crested Butte in Colorado. So a ski resort, open spaces conference, awesome, smart, brilliant people. And I'm there just kind of learning from all of their brilliant, minds and all of their experiences. And in this open space conference, in the afternoon, we had a hackathon sessions. And this, year, I think it was 2012 or 2013, Twitter Bootstrap had just been released. So we were in one of the apartments where one of the folks who at the conference was staying, and the person's name was Joe Sondow. So Joe at the time was an engineer at Netflix, and he downloaded Twitter Bootstrap, and he was going through the process of figuring out whether or not he liked and trusted Twitter Bootstrap enough to put it on his personal website. So he was looking at the code, he was reading the code, he was writing bits of his own code that was kind of pulling in the Twitter Bootstrap framework to make it work. He was thinking about things, he was trying to understand things. And what was awesome was that Joe, he had a laptop plugged into a big TV screen. I've still got a photograph of it happening. He was narrating out loud what he was thinking. He was narrating out loud what he liked. He was narrating out loud what he didn't like. He was narrating out loud his surprise, all of these different things. And so it was super interesting, super cool. I learned loads about Twitter Bootstrap. But what I began to realize as this kind of session went on was that how Joe thought about code was very, very different from how I thought about code. How Joe read code was very, very different from how I read code. How Joe wrote code was very different from how I wrote code. And what Joe liked and didn't like, what surprised him and didn't surprise him, was very different from me. And so if I'd have kind of gone, out and had a drink and then not stopped worrying about this, then maybe this wouldn't have kind of triggered this crisis of confidence, which has kind of went on for many years up until very recently. Maybe this talk would never have happened. But this kind of question about how do I know if I'm doing development right? If I'm doing it so differently from Joe, and Joe works for Netflix, right? So Joe's good at this job. He clearly knows what he's doing. How do I know I'm doing it right? Am I doing it equally right, but in a different way? Or am I doing it wrong? And I didn't, the answer to that question was, I don't know. So I started worrying about it. And like I said at the start, I worried about it so much that I started breaking it down into smaller questions. So we're now going to talk about the 5 small questions that sprung from this initial question, and kind of dig into them a little bit and see what I can share my experiences, but I can also kind of share some of the thinking around about it. So question number 1, am I thinking about code right? So again, for considering that the task of writing code is as intellectual as it is, right? Like tons of the stuff we do is up in our heads. It's the castles in the sky, right? The castles in the air that Fred Brooks was talking about. Lots of the stuff, 99%, a vast amount of our job happens in our heads. It isn't the typing. There's not a lot of typing, et cetera, et cetera. It's happening in our heads. And yet lots of what we talk about all the time, and lots of what we discuss about and read about and share about and learn about is not necessarily how to think about code. It's like, what's the syntax of a language? How do you use this framework? How do you do this? How do you, the lower level practices, but not the higher level concepts of thinking. Should, when we think about code, should we think in the raw syntax of the language that we're thinking about? Should we think abstractly about the specific problem? Should we think in the kind of, if it's a functional language, should we think in raw functional concepts, but not specifically Scala, or OO concepts or whatever? How should we think about code? There's if you actually look into reading about this kind of stuff, there's very little in our area of expertise which talks about this. So again, I can tell you another story which kind of brought lots of this home to roost for me, and made me kind of wonder about it in a way that I think, and I'll share it with you and you can give me feedback at the end, help me kind of think about this. So another story, this is a few years later, I'm back at the Java Posse Roundup, because that was the Open Spaces Conference in Crested Butte. I'm again incredibly lucky. We are again at a afternoon hackathon session, so it's kind of self-organizing. And at this time, Scala's getting big, so there's a group of us trying to learn Scala, and we're trying to learn Scala. So none of us really know Scala. We're trying to learn Scala by trying to solve a simple maths problem. And so one person, as usual, has their laptop connected up to a screen so we can see what they're typing. But now we're, instead of like before where we were watching Joe, now we're all kind of thinking out loud. We're talking out loud. We're kind of, occasionally people swap around and the screen is shared by someone else. And we're all kind of trying to work on the code and learn things out loud. And again, I realized that I was really struggling to keep up. And there was two specific aspects which I realized after, when I was kind of, again, worrying about it and thinking, am I in the right career? Am I doing the right thing? There was two things which struck me about that experience. The first thing was, it felt like my brain was full. The concepts, just trying to keep up with what people were talking about, what people were doing, just trying to type along with what was being typed up on the screen or what was being discussed. That was hard enough. I didn't feel like I had any spare brain capacity to be able to contribute to the actual writing of the code or the actual solving of the code. And the other thing was, kind of related to the fact that my brain felt full, was the fact that it felt like the concepts, the concepts that people were talking about, the concepts that people were throwing around in discussions and that they were writing out into the code, were not necessarily concepts that I didn't feel I had the same confidence with those concepts as other people who were using those concepts and talking about them. And so then I thought, this again worried me. I was like, crikey, I'm just not a very good developer. Is all of these things, what's going on? And it was only a few years later when I was trying to learn algebra, because I thought, right, I'm going to, I came away from this thinking I'm going to learn Scala, and I've got a whole series of blog posts that I wrote as I learned Scala, which are at, well, if you Google it, you can find, if you Google my name, you can find the links to the Scala blogs. Because I thought I need to do this. And then I realized I didn't know algebra or maths properly. So I went back and learned maths, and I blogged loads of stuff about learning maths. And on the process of this journey, I discovered a book by Barbara Oakley, which was all about cognitive neuroscience or cognitive science. And ironically, having done a psychology degree, I'd forgotten about this key concept. So there's a key concept in cognitive science which is stuck around for a very long time and is super relevant to this and super relevant to this discussion. And it's the concept of working memory. So working memory is the kind of the workhouse of your consciousness. It's the place in your brain, whether it has a physical location or not, it's kind of irrelevant, but it's the area of your brain where, when you're trying to do active thinking, where things take place. So active thinking could be something as simple as remembering a phone number. So Ronnie tells me his phone number and I have to rehearse it over and over and over in my head because I haven't stored it in long-term memory until I can write it down. Or we can also use working memory for things like thinking about code or problem solving or mathematics or whatever, loads of different stuff, but kind of active, complicated manipulation of concepts that happens in our working memory. And so remembering working memory, I was like, oh, maybe this is the thing. Maybe the reason why I was struggling and everyone else was not struggling is because my working memory is smaller than everyone else's. But the thing is, as I knew from psychology, and it was reinforced by reading this book, A Mind for Numbers by Barbara Oakley, and I've got a picture of it at the end if you want to check it out. Years and years and years and years and years of psychological experiments have proven that working memory does not significantly vary between anybody, not across cultures, not across genders, not across anything, right? Working memory is the same size. So that wasn't a valid excuse for the fact, maybe I've just got a small working memory. Maybe my brain is smaller than these people. So my buffer wasn't overflowing because of a smaller working memory. So what the conclusion that led me to was, and this is detailed in depth in Barbara Oakley's book, I was using that buffer less efficiently. And so this is the first kind of key point I want to make. When we actively think about and solve problems and try and understand things and write code, we're using working memory. And the things we're manipulating in working memory are what Barbara Oakley called chunks. But those chunks are chunks of mental model, right? And so if we're thinking again about building castles in the air, the blocks, the bricks that we're building these castles from are little bricks of mental model. And so therefore, if you want to fit more things into your working memory, you need more detailed, more concrete chunks. So therefore, instead of thinking, I can have a kind of chunk in my head, which is a chunk about how functional programming works, as opposed to lots of little chunks which are like, crikey, this is what the map function does, and oh my goodness, this is what the flat map function does, and all of the lower level stuff. I need a bigger chunk which can take up less space in my head, which I can expand if I need to, but I can just hold that chunk in my head. That was what I was lacking, because some of these people had functional expertise, so they could take that to this Scala problem solving, whereas I didn't understand functional programming. So therefore I had lots of smaller pieces in my head which filled up the number of slots I had in this space in my working memory. So that's the key thing. Number one, when we think about code, I'm very convinced that we're taking chunks of mental model, we're manipulating them, we're building them up, we're combining them, and how effectively we combine them and build them up is a key thing to how experience it feels when we write code. So we'll come back to this, but that's the kind of the first thing for how I think about writing code. Think about code. But that's the next thing that we need to talk about, right? If code was all thinking and we didn't have to type it out, then then maybe the experience of development wouldn't be the experience of development that we have now. But it's not just the act of thinking about code. It's also the act of communicating code to the outside world. So again, this is considering the fact that we do it a lot less than we think, than the time we spend thinking about code, but it is a significant element of what we do. And when we come to the end, I'll tie everything together, and I think it's very significant. I think it's something that we don't think about enough. I think it's something like we love talking about keyboards, we love talking about keyboard shortcuts, we love talking about whether people use Emacs or whatever, but I don't think we talk about the purpose and the way that that we communicate what is in our heads, what the concepts that we've created and constructed in our working memory, how we get those out into the outside world and onto the computer. I'm not sure entirely we talk about this enough. Having spent a lot of time thinking about, number one, how we think about code, I've become more and more convinced that watching people write code gives you a really, really interesting insight. And this was my first insight into how the mental part, the thinking about code, is working. So I described how, like I don't write code how the same way that Joe writes code. Joe had a very kind of measured, slow, very little typing approach to writing code. He would think a lot, he would craft it and construct it nicely in his head, and then he would kind of top to bottom write the piece of code that he was thinking. When I wrote code, I do it completely differently. I'll like blast a bunch of stuff out of my head, kind of use that space that I've created in my head by putting it on the screen to free up some memory in my own head and do some more stuff. So then I'll kind of come back to the same piece of code over and over again. I'll scroll up and down. I'll write maybe the bottom of a function, then I'll go back to the top. It's a very different experience. And I'm now convinced that there's not necessarily a right way or a wrong way. And I've now discovered from pairing with people through my career at ThoughtWorks and before, that every single person has a different way of doing this. But what's clear is, or seems clear to me, is that the way people write code is a really interesting insight for that person and for others working with them, insight into how they think about code and therefore how they capture it. So again, I don't know if I'm writing code right, but I think that's actually one of the, the way we write code is not necessarily something to be worried about or something to be concerned about. But I think if using it as a tool for looking back into how we are manipulating these concepts in our heads, I think that is super important. So that's something that I think we should think about more. So the next crisis that I had is number 3. So we've covered how we think about code, which probably doesn't surprise anybody. We've now, then we covered how we write code. And again, if our job as developers was purely restricted to thinking about code, which is awesome and fun, and writing code, which is typically a bit of a labor of love, but not necessarily a bad thing, our jobs would be super easy. But as numerous studies have shown, and we all know from experience, reading code is a massive part of our job. And it's a massive part of our job, which I, again, don't think we don't talk about, we don't investigate, we don't dig into and kind of have a think about anywhere near as much as I think we ought to. And so again, I spent a lot more time thinking about what is going on, as it says up here, what's going on when I read code, right? Because I think there's tons of stuff going on when I read code. And I think by thinking about what is happening inside our heads when we read code, I think a great deal of insight can be gained for things. So the fact that the fact that I think there's a really valuable and important thing that we need to consider, or lots of important things that we need to consider when we read code, but the fact that it's not treated seriously in the books we read and the courses we take and all of those kind of things is summarized in in this cartoon, right? So typically, lots of, especially British people, if something's important, British people won't take it seriously, we'll just make jokes about it. And this is, I think it's American, but it's a similar thing, right? And so I'm sure everybody's seen this, this code quality metric, but like all good jokes, there's a lot of serious stuff in here, right? So, WTFs per minute, I think is actually, and I think we all agree, is probably, it's a very crude and cruel metric, but it's probably the best metric for code quality that we have, right? So for people who haven't seen it before, on left, there's a few kind of key things, right? On the left is the good code. Interesting to note, there's still a few WTFs coming out from the room, right? And then on the right, there's the bad code, right? So loads of people going, oh, this is terrible, this is terrible. So each of these stories wouldn't be a story as part of this presentation if I didn't mention the crisis that I had. I also had a crisis when I first saw this comic. So I think from speaking to people and everyone else, because I kind of checked at the time, I think when people read this, people think this is funny and they relate to this because they've all put themselves in the shoes of the people doing the code review. And they're like, yeah, man, code does suck, right? Whereas when I read it, I immediately put myself in the shoes of the person whose code was being reviewed, right? So I'm like, oh no, this is like, that is my worst nightmare. Because it's easy if you've got tools in like cyclomatic complexity and linters and all this kind of stuff, it's easy to write code that passes those things and is pretty good, even if you're following things like clean code, right? They're good things, but they're rules that you follow, and you can make things past those things. But you can still, even when you follow all of those, I still think you can write code which will either be good or bad, and based on a measure of WTFs. And why is this the case? This happens because, and I am really convinced about this, because when you read code, what you're really trying to do is you're trying to reverse engineer from what's written on the screen in front of you. You're trying to reverse engineer the mental state, the mental models, those cloud castles, right, made up of layers and layers of increasingly complicated mental models, right, which comprise our understanding of the language that we're working in, mental models that comprise the runtime we're running on, mental models that comprise the collections libraries, mental models that comprise the frameworks that we use, mental models that comprise other people's code in the rest of the code base. All of those chunks, right, we're reverse engineering that model into what we already know from the code that we're reading. And so, so that's hard. And so therefore the code needs to kind of communicate that kind of thing. And even good code, has WTFs, right? So that's like surprise. People are like, well, this isn't what I expect. When I reverse engineered this code into my mental model, the person didn't write the code, but the person who was reviewing the code. It's still hard, right? This is really difficult. But again, we're not talking about it. I don't think we talk about this. We don't think of this, or I see very little evidence of people, thinking about this is what we're doing. We're reverse engineering this mental model of the code, because that's where we manipulate it, right? Where we think about it when it's in our heads. Everything else is just things to make it run. So that's the one. So that's the first three questions. And those are what I think hopefully everyone agrees, because they don't seem too controversial. The three kind of key steps, the key parts of our job, right? And my three crises around each of them. But I talked at the start about emotions. I talked about the highs that we got from Steve Jobs mentioned, the lows, and or the expanse and the kind of the awe that we have of the power and the potential complexity that we get from Ada Lovelace, and also the kind of the castles in the air that Steve Brooks mentioned, right? But those are all, it's all so far, apart from my crises of confidence, we've talked about intellectual activities because we're software developers, our natural inclination is to think about the intellectual aspects, the thinking aspects, the concrete aspects, the scientific aspects, the rational aspects about it. But again, I think for something which causes such heights of emotion, we don't talk about it at all, apart from to make jokes like memes and WTFs per minute and all this kind of stuff, right? But the emotions are a massive, big thing. And so that was my other thing. I realized after a while, there's the intellectual aspects, which I've kind of covered a little bit, but also I'm like, there's tons of emotion, and where's the emotion coming from? And that's what I wanted to kind of dig into next, right? So I've got lots of emojis because there's loads of different emotions, because I think like I think if anything I want people to take away from this talk is just an awareness, at least an awareness of all of the different types of emotion you're experiencing when you're working with code. And there is tons. I could have put more on, but I got bored cutting and pasting emojis from the web. But there's tons of different emotions, right? And to kind of dig us into this bit, I want to tell another story of a crisis that I had, and again with someone I worked with. Well, actually, this story is not in a ski resort in Crested Butte. This is in Aston in Birmingham, in a not very nice part of the United Kingdom. Although if you come from Aston, I'm sure it's a lovely place. But it's not nice to be stuck writing code for a long time. So I was on a project where we were still at a consultancy, and we were working on a massive code base, super abstract, gigantic Spring code base. So if you do Spring Java development, you imagine, the biggest code base you've ever seen, biggest code base I'd ever seen anyway. So it was a Spring code base, and there was some really kind of gnarly, complicated problems. And one of my colleagues, Clive, real name, and Clive has seen this presentation and agrees that I'm not making this up. Clive had been working on a problem for maybe a day, and it was some really weird, gnarly problem, and he couldn't figure it out. So he stupidly asked me if I could come and help. So then for a few hours, I'd come over, and I'd been sitting there with Clive, helping him kind of brainstorm, trying to figure out, reading all of this code, reading all of the tests, trying to understand what was going on and where the problems might be. And so eventually we kind of together figured out what might be a way, what might be a solution to this problem, or what might be the cause of this problem. And like all good developers, we were like, right, we can write a test. If we're right, if our theory is right, this test will fail. So we wrote the test, started running the test, because it was a gigantic code base. The test took a long time to run. So while we were waiting for the test to run and start up the Spring context and all of this kind of stuff and load all the beans into memory, we bet each other what the outcome of the test would be. And so Clive reckoned that the test would fail with null, and I reckoned that the test would fail with 1 or 0, I think. And the test finished, and Clive was all right and I was wrong. And so immediately again, so things started happening. So we both experienced really strong emotions. Clive experienced incredibly strong emotions because he'd been looking at this for a very long time, so he was super excited. And he was really chuffed, really, really, really upbeat, really super happy. I was the complete opposite. I was like, what? And that, again, later on, when I came to think about it, I was like, why, Clive and I had been looking at the same code, understanding the same things, because we understood, we looked at it in the same ways. Clive had done the typing, but we'd only written a test, so it's not like the act of typing had made Clive's experience vastly different from mine. The only thing that was fundamentally different was that Clive had predicted that there would be a null, and I'd predicted that there would be a 0. And again, this kind of made me go away and think about things. It's like, there was a significantly different emotion about all of these different things, right? And so it made me kind of step back and wonder, why was I experiencing this different emotion from Clive? And it wasn't just from the fact that, I would occasionally question my abilities as a developer, because, we solved this problem together, right? It was an equal partnership kind of solving of the problem. So let's kind of recap all of the pieces, because I want to now introduce the second piece of science and stuff, which I think ties a lot of this stuff together and makes it, not only explains all of the things that I've introduced so far, but adds to them, and also, we'll talk about in the fifth question, gives us an into using emotions and understanding emotions to make us better developers. So we talked about how there's the thinking about code, the bits where we're creating and manipulating our mental models, and we're doing that in working memory and kind of other parts of our mental apparatus. Then there's the communication of that code to the outside world via typing and using our IDEs and things. And then there's the reading of the code, but there's also the kind of parsing of the output, right? So there's watching our system running, reading logs, watching the output of unit tests, and all of these different kind of things, right? And we talked about how when you're writing code, you're kind of reverse engineering the first state from the code that you're reading. So, and all of these things seem to be, potentially the source of emotions, positive things, negative things, different types of experience. And so they all kind of fit together. But so what I realized was that they actually fit together like this, right? And we love loops as software developers. So we think, we communicate the things in our head to the outside world. We then kind of run those things or get the feedback from the IDE or whatever, right? And then so we're perceiving the IDE, so our senses are perceiving it, and then we're kind of the consequences of that are being mapped onto what we see and what we know, and then we kind of keep going around, right? So there's definitely a loop. There's a feedback loop, just like there is with the TDD feedback loop, just like there is with the pair programming loop, just like there is with the CI/CD loop. There's a loop going on, and so I think that loop is a really important loop, and I think it's something we don't think about enough. And this is where I want to introduce the second piece of cognitive science, and this is cognitive neuroscience. This is stuff that's kind of happening right now. So if you want to learn more about it, there's a book I've posted at the end, but there's a concept in cognitive neuroscience called the predictive mind. So the predictive mind, which is written up in this book with the same title, by Jacob Howie. And what that proposes, and it makes tons of sense to me, is that what we have in our heads is not like a representation of the outside world or a representation of the world in which we live, but it's a predictive model of the world and where we live, right? So if you're interested, they reckon it's a Bayesian predictive model, right? So and they've modeled all this stuff so that you can get from nerves all the way up to really complicated neural states which model the outside world. So then you've got in your head, this predictive model. So what is perception? Perception is you take the predictive model in your head and then you map onto that the sensory input that you're getting. And if your sensory input corresponds with your predictive model, then you perceive it. And if your sensory input doesn't correspond, then something else needs to happen. So you're not modeling the outside world. You're not seeing the outside world. You're kind of predicting the outside world. And then you're mapping on what actually your senses, your eyes and your nose and all of this kind of stuff tell you. So if your predictive model is correct, which it is a vast amount of the time, then everything is fine and the cycle keeps on working, right? So therefore, you know where you are in the world, you know what's going on. So therefore, you can act, you can move your hand, you can move your body, or you can interact with the world or whatever, right? But if these two things don't map, if your predictive model doesn't map onto the sensory input, the input you get from the outside world, then they say you experience what's called surprisal, but they mean surprise, right? So you're surprised that the outside world doesn't map onto the inside predicted world. So this is how they say everything works. But if we take a step back and say, they've got these mental, we have these mental models of the outside world, and then we're kind of doing all these things and going in these loops. All we're doing in software development is we're kind of jacking up, completely amplifying this process, and we're building on top of this process to build these abstract cloud castles in the air, right? We're physically manipulating in our head and then communicating those out into the outside world via keyboards and mice and IDEs, right? These ideas in our head, these things. So we've got this model of what we think, it's not a model of what it is, it's a model of what we think it should be. We communicate it to the outside world. And then we run the code, we run the tests, we put it into production and see what it does. And then we get the feedback from what happens. And if we're right and our code is good and it maps onto what we think, or if we're lucky, then we get zero surprise. But if there's something wrong, if something is different, then the sensory inputs, the things that we see and perceive, are different from what the models we have in our head, and we experience surprise. So that's surprise, but where does the emotion come from? So Howie and all of the other people who work in this space also talk about emotion. So emotion, we don't just predict the outside world, we also use the same mechanism they predict or they propose to kind of to predict our inside mental states as well. And so when those mental states are as we predict, that surprise is interpreted as positive emotion. And when those mental states and what we perceive are different, when we experience surprise, we kind of negate and process that surprise using negative emotions. So there's this concept of these things coming around where surprise is turning into various different forms of emotion. So I think this is a root of something, you know. So therefore, emotion isn't just the fact we're super frustrated because this thing hasn't worked. There's more value to this thing, and that's where I want to get to the last kind of step. And so the way we interpret this difference, the way we interpret this emotion, gets processed in 5 different ways, and this is the first one. And the way we interpret them is directly related to either where we give the most weight, right? Do we give the most weight to and most importance to the models in our head, the things that we predict, or do we give the most weight to the things that we perceive? So option number 1 for how we process, you know, this incoming sensory information that something has happened. We can doubt that we can trust our mental models. We think our mental models are still correct. We can also trust our perceptions, but we can doubt step 2 that we typed the code correctly, right? So our mental models are still right, but we probably just, you know, typed something wrong. That's the first one. Step 2, we can doubt ourselves, right? So we can doubt our mental models, the high level, you know, the mental models fit for the problem that we're trying to solve. So we still think the mental model in our head is cohesive and comprehensive, but it's not solving the problem that we're trying to solve. But also we don't doubt the perceptions that we come in from the outside world. Number 3, and this is where it gets a bit more, you know, closer to harder, kind of tougher emotions. Number 3, we can doubt the integrity of our mental model. So we're like, actually, maybe something is wrong with the mental bricks, the mental model chunks that we've used to construct our overall mental model in our heads. Or even more fundamentally, we can doubt the underlying mental model building blocks, right? So maybe we thought we understood flat map, but maybe now that we've written some code and we've used flat map and the results of our code that we're being presented with do not map how we thought flat map worked, you know, or do not map onto how Java, you know, collections libraries work or whatever. And then the final one, we can doubt our perception. And this one, I think, is one that happens most, because what you see is people all the time, you know, maybe we should spend more time doubting number 1 or 2 or 3 or 4, but what we doubt all the time is we're like, this must be right, the thing in my head must be right. So therefore, you know, how many times have we sat in front of a screen for hours and hours and hours, and then someone comes along and goes, oh, you're missing a semicolon, and we're like, what? Because we literally haven't seen it. So all the time, what we do instead is we doubt our perception. We're like, the things that the fact that this test is failing is literally not there because we can't see it, because we're not giving enough credence and enough weight to the perception things. So those, I think, are the 5. If we have this loop, if we have these kind of mental models that we're building up, and if we have this predictive mind model where we are comparing what we perceive and what the outside world is, and our code is running in the outside world is telling us with the model of what we expect it to be, these are the 5 ways I think it can work. So number 5, what does this tell us about the varieties of development experience? So what I want to pull out first is, and again, I've spent quite a lot of time thinking about making sure that this works. I think first it's important to remember which bits don't differ. There's lots of different people write code in lots of different ways, right? But there's certain things that are the same. So as I said, number 1, I firmly believe that we write code by creating in our heads, you know, these air castles that are made up of chunks of mental model, and those chunks are made up of smaller mental model, and those chunks are made up of smaller mental model, and the chunks are manipulated in working memory. And working memory is the same across everyone. So we're all putting chunks in our working memory, which is the same size, and we're all, you know, using that. The things that might be different there are the solidity or the confidence or whatever that we have in those mental chunks, and the chunks that are available to us, right? If we move from OO to functional, maybe we don't have these functional chunks in our heads to manipulate. So if we want to learn them, that's the kind of stuff we need to focus on. Beyond that, everybody also has this kind of predictive, you know, the models you have in your head are not full models, they're predictions of what you think. You then communicate that out to the computer in the outside world, and then the running of them and the perception of the outputs of that loop and the mapping of that perception versus and compared to the prediction that we have in our heads, that loop is also happening to everyone. And again, there, the difference that spring, you know, these varieties of different experience springs from how we interpret the surprise which emotions we lead to when our prediction and when our actual real life, real world outcome don't match. So, and those come from where we put most effort. Do we put more effort, or sorry, more emphasis? Do we put more emphasis in what we see and what we hear, or do we put more emphasis in what we have in our heads and how correct we think that is? And I think those are the angles, those are the degrees of freedom where if we think about those things, that's where I think we can understand more about how we are as developers, how we think about things, how we can learn, how we can improve, how we can collaborate, etc., etc. So with that in mind, and I'm good because I've not run over time. Given all of this, I want to come back to the question that I asked at the start. So at the start, I said, how do I know if I'm doing development right? With all of these things in mind, and I've been kind of trying these out secretly, not secretly, but with myself for quite a year or so. The reason I wrote this talk is because I wanted to share this because it's proved super useful to me. So the question I now want to ask everyone on the call is, how might you know if you're doing development right? And it allows me to ask the question. It's like, so lots of people have said when I did this last time, they were like, yeah, but this is, maybe we're not as tuned into all of this kind of stuff, or not aware of all of these things. And so that's a very valid point. I think there's a few things you can do which you can use to directly confront yourself with all of these concepts, and therefore you're kind of going to have to learn a lot from it. And the two things, and I'm contractually obliged as a thought worker to say this, but the two easiest ways to confront yourself with these things are to do TDD, because TDD kind of makes you do a far more tighter iterative loop, and it makes you be confronted with the accuracy or inaccuracy of your mental models far more frequently. But even more than that, pair programming, because pair programming, just like I said when I worked with Clive, pair programming will make you A, super aware of your mental models, but B, it will make you super aware of the differences between your mental models and the person you're pairing with. And one of the big aspects of pair programming is having this shared mental model is the thing you cultivate as pairs, but that's really flipping hard. And this is one of the things why I reckon pair programming is super hard, right? So what you do is you pair program, and then very quickly you become aware of the difference in emotions, the difference in mental models, the difference in styles of everything, the way you can type and all of this kind of stuff. So you kind of supercharge and rocket fuel charge the differences and the experience of those differences between you and your pair, and you'll get all of this feedback. And then with that information, and I propose this framework, you can use that to think about where you're at, what you're good at, what you know, what you don't know, what you're maybe putting too much faith in, what you're not putting enough faith in, and to give yourself credit for the stuff that you're doing well, right? The stuff that you're good at. So I've used it as a development mechanism to kind of help me and help my career and help me learn things. And I think that it kind of makes sense for others to do it too. So that's the end of the talk. I see there's 3 questions in the Q&A, and Theo has said something as well. Those are the 2 books that I've mentioned. You don't need to read those books, although they are both really interesting. But I'd love to hear what people think about this. Do they think it's completely barmy? Hopefully I explained it well enough that it makes sense. But does anybody have any questions or thoughts or criticisms or challenges or anything? Because like I say, lots of this has come from personal experience, which is not very scientific. There hasn't been any psychological studies based on this. It's just me making this stuff up. So,
Andrew, I think there's one question, because I think it was rephrased in a Q&A, and then otherwise it might be a few more.
Yeah, cool. So, Theo, curious about was with writing and reading about code in larger systems software architecture.
I think the third one.
Yeah.
I think if you go to the third one, because I think Theo rephrased it. So I think the only real question is the last one, 1838.
Oh, got it. Oh, sorry, 1738. Yes. I'm curious about what happens when writing or reasoning about code in larger systems or software architecture. Developers like to develop and avoid any activities not related to writing code, such as documenting management, etc. So yeah, I completely agree, Theo. So this is I think more and more, like it's a miracle to me that groups of larger than one person write software that has any coherence at all. based on how hard it is to write. Like many languages are easier to write than they are to read, right? The way we structure our code, I spend quite a lot of time thinking about it because I'm not a very good developer, right? So I need to spend time, because I'll come back and read my own code 3 years later and I'll be like, what idiot wrote this code? And it was me that wrote the code. And I think the reason we are is because there's a lot of really smart people who work in software development, right? Some people think they're not good developers. I think, just to be able to commute to provide, work on a code base which is years and years old, which has been contributed by loads of different people with changing requirements and all of this kind of stuff. I think it's a miracle that it works sometimes, and I think that's one reason why I think a kind of bigger awareness of the mental models and how we get this stuff into our heads and how we communicate with it. I think that would help us give ourselves a break when things are hard. I think would help us focus when we don't know what to work on and what to emphasize. I think it's the reason why it's one of the least talked about XP principles is the system metaphor, which the more I think about this, nobody talks about system metaphor, right? Like TDD is an XP practice, pair programming is an XP practice, continuous delivery is an XP practice. So is systems metaphor, but nobody talks about it. But again, I'm like, it makes me think that Kent Beck and the rest of the XP people, they were like, if we have to have this shared mental model in our heads, a system metaphor is a really smart way of at least putting us all on the same page to go, this is the rough outline of this castle we're building in our heads, right? Because we're all building the same castle. And unlike when we're building a real world castle, right? I'll work on one bit, Ronnie will work on another bit, Vanessa will work on another bit. We're all probably working on the same bit at the same time, and then we move around and we come back to someone else's bit. I think there is a place for lots of these things. I think the code is the most important thing. I'm not going to be some person who goes, oh, we should do loads of documentation on top of it. But I do think there's a place for like orientation things or bigger picture things or structure, or it's why I like microservices, because microservices is a nice way of doing a larger structure on top of smaller structures. And microservices are nice because it keeps them bounded, right? It's very hard to bleed a concept across 7 microservices because you need to try hard to do that. Whereas on one big code base, someone can come in and smear like a big, messy abstraction all the way through stuff. It's not necessarily a very clear answer, but I think I think all of this kind of stuff, if we think about it as basically the value is in the mental models. It's why I love DDD, right? Getting clear mental models and co-creating them with our business people. Vanessa, no, like I can't do a talk without mentioning DDD, but that's the power of DDD as well, right? It's like, right, there's already all these mental models out there. Let's mine those mental models rather than creating a completely fresh one, because this stuff is hard. It's a miracle to me that we get any of this stuff done. So.
You see, you just preempted my question, Andrew. Interestingly, what I wanted to ask is, do you reckon, so in your talk, which was very interesting, and thank you, you do mention how people might feel insecure or worried, some of the feelings that people might feel because they're not sure their mental model matches what they're reading, what it should be, or any of those circumstances. Do you reckon that actually another way, because you mentioned, pair programming and TDD, do you reckon that working together on domain modeling in general in different ways might help, somehow streamline these feelings or support them? Or do you have any suggestions around that?
So I think it depends on how people think, because it's what's become really clear to me as I've thought about this. Because what's interesting is by doing this, I've learned a lot about at least this is at least a description of how my cycle works. Maybe other people's are completely different, but so some people think like that, some people don't. I think the real genius of DDD is the ubiquitous language, because language is such a fundamental part of our brains and how they work. And language can, models and diagrams don't really make it into code, but language makes it into code, right? So, and this is the genius thing. If you're a business user or there's some business concept, right, with like an invoice or something, and you put that in code, if that's in code and then you're reading the code and you're like, well, I've already got a mental model of what an invoice should be from the fact of what I think how this works in the real world, and now I'm looking at the code and it's different, you're opening yourself up to signals that something is weird. One of them's wrong, one of them's right. Maybe the code is right, maybe the person speaking telling you in the real world is wrong, but you've opened yourself up to this kind of this mental model which is already there. And I think that's super powerful. I think that's because we're not just, you know what I mean? We're not just typing a series of instructions. We're creating a mental model on top of smaller mental models, which on top of other, you know, it's really interesting to me to think about bugs. Nowadays, more and more bugs that I see just look like the fact that someone's mental model, nobody writes code that's wrong on purpose, but their mental model might not be complete, or they've applied the wrong mental concept, mental chunk to the problem that they're trying to solve, or there's a weird sharp edge of Java, right? You see this all the time, which isn't actually a consistent mental model with all of the other parts of Java, right? Java's full of them, for example. So you've written Java like you think Java works, but this bit of Java doesn't work like all of the other bits of Java, right? So therefore, the thing that should work, it doesn't. If you see that and suddenly you're looking at bugs, and also if you listen for developers expressing surprise, you know, as the thing before it turns into emotion, you'll hear it over all conversations. People will be like, oh, I didn't think that was going to happen. That was disappointing. That, you know, but all it's like, I thought it was this and it was actually this. That's everywhere in development, I think, all over the place. People be like, oh, my expectations, you know, your predictive mind, right? My expectations of how Scala worked are not like that. It's really interesting. So now I hang out on Slack rooms nowadays and just harvest people expressing their surprise at why Go or like Kotlin coroutines don't work how they expected them to work and stuff like that. And I'm like, oh, that's interesting. It's because their mental, the chunks in their mental model are different from what the actual language implementation is. So Theo's TDD makes sense. You know what you're aiming for, not as an explore concept when building a proof of concept, right? Yeah. So it's an orthogonal question, but the reason I mentioned TDD is because it's like a crowbar right into the middle of how some people write code. So I love TDD because I said before, for whatever reason, my chunks seem to be smaller than some people. So I need a nice way of getting everything flushed out of my buffer onto the screen as quickly as possible. And TDD makes me think about, you know, don't think about the implementation, think about the problem, red test. Then it makes me think about, right, now you've got the test. You don't need to think about the problem. You need to think about what the solution is, make it go green. Now I'm free to do the refactoring and make it clean, refactor, right? Repeat. To be honest, so this is the thing. So some people, this is where it's interesting. Lots of people are like, I don't like that constraint when I explore problem spaces. I still do like that constraint when I do problem spaces, but this is where it's really interesting, right? Thought workers come in all the time and we're like, TDD is the best thing ever. It's the best thing since sliced bread. But sometimes we forget, and Vanessa and I have done this, like we didn't forget, but just because you can't TDD doesn't mean you're a bad developer. It just means your experience of the loop and how you work and how you think and then communicate to the outside world and process the result. TDD is a real straitjacket on that, and sometimes it fits beautifully and people are freed by it, and other times it gets right in the way and they hate every living second of it, because this loop is a completely opposite to TDD. And just like you said, Theo, some people, when they're exploring, they just like write code because that's it. They kind of flow straight out onto the page. And it's far more kind of organic and kind of fluid. Other people still like that thing, like me. I like thinking, what's the problem? What's the solution? What's the refactoring? Right? Kind of loop around. But it's really interesting. I think, again, having this mental construct has helped me build even more empathy for people who are like, I really hate pair programming. Or TDD sucks. I still think they're super powerful. And I think like when you see people who get it, it's exciting. But having this in your head, at least, you know, even if it's wrong, right? This is just me making stuff up based on the fact I've read a few books and I did a psychology degree. It really feels like it makes sense. You're like, oh, that's why that person isn't, you know, I'm trying to tell them to do this, but that's not what they do. They think of everything. They think of red, green, and refactor in their head, and then they write the code. And I've just told them to do red and not green and refactor. So it's, yeah.
If I can add something, I think even in the question, there is a tone of feeling towards the experience of development.
Yeah.
So the feeling of, you know, feeling constrained, of not being able to follow their creative way,
yep,
is a feeling that you feel during development. I will add that I'm absolutely biased on TDD, that probably if you don't know what you're aiming at, it's likely that requirements could be written better. Or that if you are, experimenting with technology, then that is not something where, maybe TDD makes sense for you. But I wonder, Andrew, just to follow up on this, right? So you mentioned how pair programming and TDD could be ways for us to try and better understand this experience.
Yeah, because it makes it painful. That's why they're good. Because they confront you with all of these, the loop, you can feel it, I think, right? But sorry, I keep going.
I find a lot more painful not to do TDD. I find it really difficult. That aside, personal, again, the experience of development. My question was, I'm sure that this comes from lots of introspection, right? So it doesn't just come from acting, it's not just about doing TDD or doing pair programming, or you need to actually understand your feelings, right? So is there any other suggestion that you would give to people on how during maybe a pairing session or any part of your development life cycle, how you would try and listen to this so that you can actually act on it and not
this is why I think this is how I got here, because I started with the first question I asked, because I've reversed the order for this talk. The first question was like the thing that was the difference in feeling. Like I was like, it feels different to me between me and Joe. It feels different between me and Clive. It feels different between me and all of the smart people who are like, writing Scala. The feel like paying attention, like, because this is the thing, and this is why I think it works for software dev. There'll be lots of subtle feelings that will come and go, right? Which I think you tune into as you do more of this. But like, there's such gross feelings as well, like, I mean, like, it doesn't, like, there's a lot of memes around about like flipping heck, like, dev is hard, right? People throwing computers out of screen, you don't need to be that in tune with your emotions to realize, just to pick up the big ones. And then you pick up the big ones and you're like, right, okay, stop. So what is, and going to those 5 points, which I kind of rushed through a little bit, but I've come back to again and again. It's like, right, so I experienced an emotion, which, assuming that's come from surprise, i.e. something I didn't expect, where did I expect it? And what was actually the thing? Did I put too much emphasis in this bit of the flow, this bit, the thinking, my mental models and the thinking bit, what I perceived or what I wrote, and using that to introspect, I think it makes me better at debugging and solving problems, right? Because I'm just like, because then you can use the computer, you use what you think and what the computer tells you is actually possible. That's a feedback loop, right? And so tuning into that is good. But the real one is if you start tuning into surprise, because I think we're quite, like I say, if you read like Reddit, or you read like Hacker News, or you read like, there's a few Slack channels I'm on with a bunch of people, and or internal at ThoughtWorks, and I'm sure everyone has a Slack channel wherever they work. If you just watch out for people going, oh, I didn't expect that. I don't like Scala because, and it'll always be because I don't, this doesn't conform to my expectations. So there was a chat today on the Python thing in the Python channel, and Luciano Romalo, who was on one of the slides that Ronnie shared at the start, who wrote the Fluent Python book, he's like, there's a difference between people who like Python and hate Python. The people who like Python think that meaningful white space is a good thing, and people who think meaningful white space is a bad thing. And the difference is like they expect it to be good and they expect it to be bad, because there's no difference. It's still meaningful white space, but it's whether or not that kind of chimes with their expectation. I was like, that's really clever. And I think this goes to like why we like certain languages, why we like certain tools, because that's the varieties, right? There is no, the subtle subtext is there is no right answer. There is no, am I doing development right? The question is it the best fit for me with my skills at the moment where I am now, working with the team I'm working with on the code base I'm working in? That's what you can ask yourself. Sometimes the answer is no, this isn't optimal. And, and then it gives you, I think, maybe my chunks aren't good enough. Maybe I don't know Scala well enough. Maybe maybe my tooling's bad. Maybe I'm not flushing the buffer from my head onto the page more often. All that kind of stuff.
I have kind of two questions. You mentioned earlier that some languages are, make it easier to write things than to read things, right? I found myself lately judging or, considering languages where there are too many different ways of doing the same thing, right?
Oh yeah.
And as you were saying, there's a richness in this variety of different people perceiving and communicating. I like the fact that when you when you presented the slide of how do we write code, you said, okay, how do we communicate our models to the rest of the world? So it's not just to the computer, but it's also for our colleagues, right? So this richness, this very different way of expressing your ideas, should it be, in your opinion, more harnessed by the tools we used, or the fact that, I remember the first time I was reading Scala, I was amazed by all of the things you can do and implicits and all of these things. But then when you come and read someone else's code and you don't really understand what's going on. So what do you think about, this it's a spectrum probably.
Yeah, and this is the thing, it totally depends on the individual. So like, I like strongly typed stuff because it's a nice enabling constraint, but I don't like languages which only let me write code in one way. Like Go, like it's very strict, right? And there's the checker and all that kind of stuff. I don't like Go for many reasons, but it's really interesting, but it's less fluent, right? So you could argue, based on what I said, that like Python and Ruby and stuff, right, which are like super, dynamic and really flexible and all this kind of stuff, I should like them more. They terrify me because I use types. I think in types. I like the fact that the compiler will tell me if I'm being an idiot. Whereas like in Ruby, the compiler is going to not, like even runtime, it might not even tell you're an idiot, right? Like you can go a long way and get stuff really wrong. So again, it's individual preference, but I think it's like, it comes back to how we think. And again, I think this kind of framework helps me think about, why do I like this thing? Why do I not like this thing? Why do I like working with this environment? Why do I not like, and frameworks as well, right? I think personally, I like libraries as opposed to frameworks because I don't like to be constrained. But I like libraries I can compose and I can pull things together. Other people are like, this is awesome. Half of this, the scaffolding of the castle is already built. I just need to fill in the rooms and decorate them, right? Awesome. Some people like that. I'm like, no, I want to do more. I'm coming from a DDD perspective, right? The domain is the shape of the castle, right? So Spring is going to tell me I can't do this thing. And I was like, screw Spring. I don't like Spring, right? So it's really interesting. And that kind of, again, I don't think we think about this enough, right? We just kind of like wrestle with it down in the individual specific thing. But there's this bigger picture. It's like, what are we trying to do? And we're trying to do it with a group of people. That's the thing. Again, I'm still amazed that a group of human beings can create anything that looks like a working system sometimes. So yeah, conversation over inheritance, exactly right. So yeah, has anyone got any other questions? I don't think there's any.
Quick time check, Vanessa. Do we? Okay, we're slightly
over. That's what happens.
If there are any more questions.
And also, I've got my phone on mute, so I don't have it. But if anyone has any other questions or comments, even if they think this is completely insane and anything, I'd love to hear something. Like, I'm on Twitter at AL94781, which isn't very, it's not very memorable, but it's AL, not one, AL94781. Yeah, and I'd love to hear from people if they think this is, or even if they try this and it's completely barmy or whatever. I'd love to, because for me, it's been super useful. Might only be me, maybe it's just me, but yeah. And hopefully I explained it. If there was some bit that was completely unclear, please poke me and I will try and explain better. So. Yeah, no more questions. Right, thanks for coming, everybody. I'll let Ronnie, do you have to say goodbye to everyone?
Oh yeah, I will do.
Oh no, so you don't have to, but yeah, cheers, Marco.
So yeah, if you stop sharing, I mean, I'm.
Oh yeah, sorry.
On YouTube, but yeah, no, it's fine. So let me share my screen again, just for the final bye for us. So basically, thank you all for being here. One thing, as I think Andrew already said this, especially with this talk, I personally really appreciated it. It's so different from other stuff we heard. So it is, as I understand, an ongoing thing. So keep the conversation going if you need some time to settle these ideas, and then get in touch with Andrew. I'm sure he'll be interested. We will distribute a feedback form, just quick questions. You can make whatever you want with that. And we don't have right now the next event scheduled, but please make sure you subscribe to the meetup page, and so you will get notifications as soon as the next event will be announced. And thank you very much for being with us. Thank you also from Vanessa, of course, and Andrew.
Hi, thank you.
Good evening for everyone. Bye-bye.